Hello everyone, I'm Leo. My partners are Vincent and Tsungyen Yang. Today, we're going to introduce our study. Before we start our presentation, let's take a look at these two videos first. In the first video, we put an aluminum brick on the scale and a support. We can get a constant value on the scale. It's nothing special. In the second video, we put the same brick on the two supports and a scale. The whole system seems to be as stable as the last video. However, as time goes by, the data of the scale keeps changing. Quite interesting, right? This phenomenon is called indeterminate structure. Our research is about this dynamic process. And then I'm going to introduce our device which was shown in the last video. As you can see in the picture, there's a brick on the supports. We call the support in the middle central support, and the right one is called edge support. We define the distance from the central support to point C as AL. Next, we're going to talk about how we carry out experiment 1. First, we set up the computer and the scale, and make sure that the data can be read on the computer. Second, we step up the device, and that the length of the AL equals 0. Third, we collect data on the computer. Then, we repeat the step from 1 to 3, and graph wait virtual time. Next, we define left as negative and right as positive. We change the length of AL to 2.55, negative 2.5, negative 5 centimeter. And repeat step 4. Last, we analyze the data. These two figures show the data changed when AL is negative 5 centimeter. These two figures show the data changed when AL is negative 2.5 centimeter. These two figures show the data change when AL is 0 centimeter. Compared with the last four figures, we can know that the smaller AL gets, the more significant effect on data will have. The two figures show the data change when AL is 2.5 centimeter. These two figures show the data change when AL is 5 centimeter. Based on our observations, we support that the change can be fit with exponential function. We suppose the relationship between N1 and time as the PowerPoint shows. N1 is the data on the scale, and we can get A, B, C from the fitting line. Among them, B is what we want to discuss because its unit is 1/2, while A's and C's units are Newton. According to the data we got from the experiment, we find out that B is symmetric. We define the mass of the brick as M, length of which as L. And we define the modulus of electricity as K and K1, and damping constant as beta and beta 1, just as what the picture below show. When K, K1, beta, beta 1 approach infinity, then K almost equal K1, beta almost equal beta 1. Based on the Newton's law of motion, we can get lots of equations. After solving them, we can get the equation below. We discovered that the result we get from the experiment 1 is quite different from the theory. As for why, further discussion is needed. And that's all we want to share with you today. Thanks for listening.